Okay, so just to wrap up this unit on different ways of collecting samples, we've talked about a simple random sample, we've talked about stratified sampling, we've looked at systematic sampling, and then we also looked at cluster sampling. This is saying that the student body is in the auditorium. Okay, and note that the seating assignment in the diagram below. So you can see these are the seats here, these little yellow boxes. Okay, it wants us to describe how you would use the following sampling methods to select. The goal here is to select 80 students to complete a survey. Okay, and so we want to describe how could we choose 80 students if we were going to use a simple random sample method, or a stratified random sample technique, or finally a cluster sample technique. Now, do take note that they didn't draw in the whole auditorium. I think they were hoping that you would see that there's a pattern here. There are 20 students that fit along these rows, but then you'll notice they skip. There's a bunch of seats in between here, and it fills up and takes up like 800 students can fit here. Also, it's definitely worth noting down here, this little box says that the freshmen fill up seats 601 to 800. The 10th graders are 401 to 600. Okay, so we basically have 200 students in each grade here. Okay, so a simple random sample, and again, I want you to think this needs to be detailed, very detailed, so that you could hand the instructions to someone that didn't really know anything about statistics, and they could kind of follow through with what your explanation is. Okay, so step number one is to just be very clear that the students' seats, or the student's seat number, is just going to be their assigned number. Okay, so if you're sitting in seat 1, you're student number 1. Okay, now since these seats are not assigned 3 digits, but they go all the way up to 3 digits, in my explanation, I'm not going to use a table of random digits to assign there. Okay, so I'm going to say using a random number generator. Generate, now keep in mind, our goal is a sample size of 80. So we want to say generate 80 numbers between, I'm going to go ahead and say 001 to 800. And then I'm going to be very clear, skipping any repeats or numbers outside the given interval. Okay? Okay, and then lastly, step 3 is I should then survey those 80 students. Okay? This is a simple random sample because it meets the 2 criteria. The first is that every single individual had an equal chance of being selected. It also meets the second criteria that every possible combination of 80 students that you could make out of these 800 had an equal chance of being put together. Okay, and that's because everyone was all in one big group. It's when you group them first into either strata or clusters or something like that, that then it no longer is a simple random sample because you're already kind of boxing them into these different categories. Okay, a stratified random sample maybe could look something like this. We would start by saying, again, the student's seat number is their assigned number. Okay, and I'm just going to be very clear because when we do stratified random sampling, they are supposed to be grouped in groups that within the group they're all similar. And so I'm going to say where the 9th grade is 001 to 200, 10th is 201 to 400, and this is what's in that box there, okay? But this is me communicating with the grader so that they understand, okay, this person totally understands what stratified random sampling is, that these people are already kind of organized into these groups here, okay? Then step 2, I'm just going to say use a random number generator to generate, now let's think about this here. Think about how we want to do this. They're in these 4 groups, okay? Group 1, this is the sophomores, here's the juniors, and here's the seniors. I'm wanting in stratified random sampling to reach within each of these groups and select a certain amount. And remember, the advantage of stratified random sampling is the result is a nice, like, proportional description, a representation, I guess I should say, of each group is kind of represented in your sample. So if I'm wanting 80 students total, then it would stand to reason if each class had the same amount of students, 200, that I should select 20 students from each group. So I'm going to say use a random number generator to generate 20 numbers from each grade level. Okay, from each grade level. So it should be clear there we're talking about choosing 20 numbers from 1 to 200 and then 20 numbers from 201 to 400. But do say this, skipping any repeats or numbers outside the given interval. Okay, and then we end with survey those 80 students. Okay, so now let's see if we can tackle what this would look like if we were going to try to accomplish getting a sample of 80 students, but using the cluster sampling method, okay? Now, a cluster is when we have them organized in groups, but the groups, like within the groups, they're like little mini populations. So I want you to think about the auditorium here, and how could we reorganize this, not making anybody get out of their seat here, but how could we reorganize this so that they're in clusters, groups that have freshmen, sophomores, juniors, and seniors in it? Okay, now granted, this isn't a full picture of the auditorium, but if you were to visualize going down these columns, okay, you're going to include some freshmen, some sophomores, juniors, and seniors. Remember, freshmen sit in the back of the auditorium and the seniors are in the front. Okay, so if we were to do that, okay, you got to kind of think through how many people are in a column. Each column would have 40 seats to it, okay? 10 from each grade, okay? So that's good to know. So we could say, for number one, let's let each column is a cluster of 40 students, okay? And I'm just going to say 10 from each grade. Okay, number two, I'm going to use a random number generator to generate, let's see, how many clusters would we want? If each cluster column here has 40 seats and the goal is 80 students, then we would only need to do 2 of these clusters. So we want to use a random number generator to generate 2 numbers between 01 and 20. And again, we have to say the same thing. I know this gets tedious to write out every time, but we need to be very clear and say skipping any repeats or numbers outside the given interval. Okay, the given interval. Okay, and then finally, survey all 40 students in each of the 2 columns. Okay, that's really a total of 80 then. Okay, so there's an example of how you could take the same situation, wanting to get 80 students, and you could, depending on your technique, you could use a different sampling method, and those all would be total fine ways to do it. Okay, so let's see if we can identify it when we read it in a problem, like which technique or strategy is being used. It says here, the Educational Testing Service, ETS, needed a sample of colleges. ETS first divided all the colleges into groups of similar types. Okay, so similar types. So they grouped all the small public colleges together into one group. They grouped all the small private colleges together into another group, etc. Okay, so each group, when you look within it, is all similar. Okay. Then it says they randomly selected 3 colleges from each group. Okay, so they're reaching into each group. They're not surveying everyone in the entire group. They're selecting a few from each group. Okay, this is an example of stratified random sampling. okay? Stratified because the strata, that's each of these groups, are all unique from each other, but within they're all similar, okay? As opposed to number 2, it says a county commissioner wants to survey people in her district to determine their opinions on a particular law up for adoption. She decides to randomly select blocks in her district and then survey, here's the key word, all who live on those blocks, okay? Anytime you randomly choose a group and then you survey everyone who was in that group, that is what cluster sampling is, okay? Okay, and finally, a local restaurant manager wants to survey customers about the service they receive. Each night, the manager randomly chooses a number between 1 and 10. He then gives a survey to that customer and to every 10th customer after them to fill it out before they leave. Okay, this is an example of systematic random sampling, okay? Okay, so we're just going to wrap this up on the last page here, talking about inference. Inference, it means the conclusion that you could draw from sampling. The purpose of a sample is to give us information about a larger population. Okay, that's what we mean by inference here. So the process of drawing conclusions about a population based on sample data is called inference. Now, why should we use random sampling, which is any of these strategies? Simple random sample, stratified random sample, systematic sampling, or cluster sampling. Those are all random processes to select. One huge reason is it eliminates bias, okay? It eliminates bias from your selection, okay? And the other thing is, the larger your random samples are, it really does give you better information about the population than a small sample. You know, if your population is thousands and thousands of people, and then you only take a sample size of 5, that's really not going to necessarily be representative of the population. So the larger sample size, that's always better. And then finally, please remember that bias is referring to any time your results are consistently or systematically overestimating what you're trying to measure, or if it's consistently underestimating what you're trying to measure. Okay, that brings section 4.1 to a close. Here are the problems